All right, so today we're going to talk about some special parallelograms. And, well, the one special parallelogram that we're going to talk about is the rectangle. And I know from your past you know what a rectangle is, but it's a parallelogram with four right angles, so four 90-degree angles. And because a rectangle is a parallelogram, it has all the properties of a parallelogram, meaning that the opposite sides are congruent, meaning that the consecutive angles equal 180 degrees. Well, that makes sense since each angle is 90 degrees. All right, the diagonals still bisect each other, very important. And like I said, all those different properties, the opposite sides are parallel, so all those different properties of a parallelogram are going to be taken on with the rectangle. All right, except we have some additional. Now the diagonals are going to be congruent, and as I stated before, all the angles are right angles. So let's take a look at that. So if I go around the horn, if I have A, B, C, and D, I don't like that B. That's a little better. All right, so again, I know that this diagonal here is bisected, all right? And I also know from my new property for rectangles is that those diagonals are congruent to each other. So I can say AC is congruent to BD. All right, now, so what I can do also is I can solve some problems. So let's look at number one. It says in rectangle ABCD, AB is 15 centimeters, BC is 6 centimeters. Find the length of a diagonal, in simplest radical form. All right, so what I'm going to do and what you should do is let's draw that. Let's draw that rectangle. Around the horn, A, B, C, D. All right, and let's see, AB is 15 centimeters, so I'm going to put my 15 there. Then I have BC at 6. I'm going to put that there. And then it says find the length of a diagonal. So I'm going to draw my diagonal here at AC. All right, now, something important that we know is that the rectangle has four 90-degree angles. And also a property of parallelograms is that the diagonal splits the parallelogram into two congruent triangles. Well, it just so happens that this is split into a right triangle with a missing side, and that missing side is the hypotenuse. So we can use the Pythagorean theorem. So I'm going to have a squared plus b squared, and I'm going to call it x squared because I don't want to get confused because I have a c in my rectangle. All right, for that hypotenuse. So now I have 6 squared plus 15 squared equals x squared. And I have 36, just doing the math, plus 225 equals x squared. And then I add those two together, I get 261 equals x squared. All right, I need simplest radical form. So I got to think of, so that's going to be x equals, well, the square root of 261. I got to think of some perfect squares that go into 261 that multiply together. Well, that's going to be the square root of 9 times the square root of 29. So I simplify that, and I get 3 square root of 29. That equals AC. Okay, number two. Number two says in rectangle ABCD, diagonals AC, BD intersect at E. All right, so let's just do that right now. Meaning, let's draw it. Around the horn. All right, so I'm going to draw my diagonals. I have to make sure that I have an AC and a BD when you're drawing that. Okay, they intersect at E. So let's fill in what we have. We have AE is 10x plus 20. Whoa, movement. And then we have CE is negative 4x plus 76. Oh, too much. All right, so now I know that AE and CE is bisected by diagonal BD. So I can set up an equation to solve for x because what I want to do is I want to find the length of BD. And I also know that AC, because it's a rectangle, I'm just going to write that down. Well, it equals BD. So if I find AC, I know what BD equals, and that's what we're looking to do. So I'm going to have 10x plus 20. That equals negative 4x plus 76. All right, so I'm going to add 4x to both sides. So I get 14x plus 20. That's going to equal 76. I hate when that happens. All right, so I'm going to subtract 20 to both sides, and I'm going to get 14x equals 56, and x equals 4. Okay, now, so don't forget to sub in. So I get AE equals, that's 10 times 4 plus 20. That's going to give you 60. And then guess what CE should equal? All right, so I'm going to get negative 4 times 4 plus 76, and that equals 60. So that whole distance of AC is 120. So BD equals 120. All right, let's go down to our, oh no, let's discuss number 3. All right, so number 3 says, if a quadrilateral is a parallelogram with one right angle. So a quadrilateral, let's see, parallelogram, let me draw some of this, with one right angle. Would this be enough to prove it is a rectangle? Well, if it's a parallelogram, we know that the opposite sides are congruent. All right, so I'm going to go ahead and do that. And if it's a parallelogram, we know that consecutive angles are supplementary. So we know that if this angle here is 90, well, that has to be 90. And if it's a parallelogram, we know that opposite angles are congruent. So that angle there has to be 90. And then its opposite also has to be 90. So the answer is yes. And the reason is that opposite angles are congruent. And consecutive angles are supplementary. All right. Now, to prove that a quadrilateral is a rectangle, it says use any of the following. Because we're going to step into a coordinate proof, not too bad at all. It says a quadrilateral with 4 right angles. That's a good approach. A parallelogram with one right angle is a rectangle. A parallelogram with congruent diagonals is a rectangle. All right, so we're given the quadrilateral PQRS, P02, Q48, R76, and S30. Well, we have to prove that that is a rectangle. All right, so what I'm going to do is I'm going to plot the points and come right back. So you should do the same because I don't want to waste your time watching me plot points. All right, now that I have it plotted, all right, one just thing I just want to point out to you, if you're plotting these points and you connect them with your line segments, and it doesn't look like a rectangle, check your points again. All right, just replot it if that's a problem. I mean, it should definitely look like a rectangle. That's just something that may be obvious, but I just want to point it out to you. All right, now, so some approaches here. What I'm going to do is I'm going to look at the line segments, and I'm going to say that I'm going to prove that these line segments are perpendicular to each other by looking at the slope relationships, and that slope relationship for perpendicular lines is negative reciprocals. So that's what I'm looking for. Again, what you can do is you can use your slope formula for these different points. So you can plug in, all right, your slope formula. All right, once again, a little too thick, is y sub 2 minus y sub 1, all right, divided by x sub 2 minus x sub 1, change of y over change of x. I'm going to count. So when I do that, I'm going to look at the slope of, let's see, PQ first. All right, let's use a little different color here. So I'm going to count 6, 4. All right, so my rise is going to be 6. My run is 4. If we reduce that, well, that's going to be 3 2s. Let me go back. All right, so the next one I'm going to do is QR. I don't like that. That's a little too thick. Messy. All right, so QR, that's better. All right, so QR, I'm going to count. Rise, run. All right, so that's going to be 2. And then I'm running negative. That's going to be negative 3. So that's 2. Negative 3, looking good for 90-degree angles. All right, let's go. Slope of RS. Okay, so RS, I'm going to count. Back to red again. This is going to be down, negative 6, and then negative 4. Okay, so negative 6, negative 4. That's going to reduce to, let's go, 3 2s. All right, and then the last one that I have to look at is the slope of PS. All right, so PS, where are you? All right, so I'm going to go down, negative 2, and then I'm going to run positive 3. So that's down negative 2, run positive 3. All right, so those are negative reciprocals. So I can start, or I can make a concluding statement now, and I'm going to do that. Please don't forget to do that. Very important. All right, that's the worst thing to grade when a student doesn't do that. So I'm going to say quad PQRS is a rectangle due to the slopes of all adjacent sides are negative reciprocals. making sorry, a little messy there, making 4 right angles. All right, now what I want you to do, key ideas, of course, and then some good algebra problems there for you to do with those properties of rectangles. And go Cats, go Knights.